Hello everyone, welcome to this session. In this session, I am going to discuss the solution of one of the numerical on the pin. The numerical is that find the amount of heat transfer through iron pin of thickness 5 mm, height 50 mm and width 100 cm. Take atmospheric temperature 28 degrees Celsius and K equal to 50 watt per meter Kelvin. The heat transfer coefficient HTC 10 watt per meter square Kelvin. The temperature difference at the base of the pin equal to 80 degrees Celsius. Estimate the efficiency of the pin. In this numerical, this is of the pin of rectangular shape. It has a thickness 5 mm and height, that is the length of the pin is 50 mm and width is 100 centimeter. And in this one, it is asked to find the amount of heat transfer through the pin. And later, the second part, what it is asked, estimate the efficiency of the pin. For that, we'll take the what are the given data first, and further we'll proceed to solve the numerical. What's given in the problem? Pin thickness T equal to 5 mm, that is a 0.005 meter. Pin height, that is L 50 mm, that is 0.05 meter. Pin width W is equal to 100 centimeter, that is 1 meter. Atmospheric temperature T infinity is equal to 28 degrees Celsius. Thermal conductivity K equal to 50 watt per meter Kelvin. Heat transfer coefficient H equal to 10 watt per meter square Kelvin. Temperature difference at the base delta T equal to Tb minus T infinity, that is equal to 80 degrees Celsius. This is of the pin which is of rectangular shape. It has a thickness T given and length L is given, that is the height given mentioned in the numerical, and width W is given. And from this, the heat is transferring to the outside ambient A, which is having the temperature T infinity and heat transfer coefficient H. The pin has the base temperature Tb and its difference Tb minus of T infinity given in the numerical. Here we need to find out the heat transfer through the pin Q, and also we need to find the efficiency of the pin. First, calculate the perimeter and cross-sectional area of the pin. The perimeter of the pin is given as P equal to twice the T plus of W, that is 2 into 0.005 plus of 1, that is equal to 2.01 meter. The cross-sectional area of the pin is AC equal to T into W, that is 0.005 into 1, that is 0.005 meter square. Then calculation of the M. The M is, we know that under root of HP by KAC. And H we know 10 and perimeter is 2.01, already we have calculated, and K is 50 given in the numerical, and AC is 0.005 we have calculated. And after the calculation 20.1 by 0.25 and 80.4 under root, and it will be M will be 8.971 by M, or M raised to minus 1. Further moving, first we'll calculate the heat transfer. In this numerical, it is not mentioned that whether it is a long pin or a end insulated pin or convection from the tip of the pin. And here one thing we have to note, that one, its thickness is given 10 mm and its length is given L is equal to 50 mm. It is almost 10 times the more than that of the thickness, and by that we can assume it is long pin. Even though if you assume the end insulated pin or a convection from the tip, little variation is taking place, but it should have the one base to assume. And that's why more than 10 times if it is there, then we have to take the long pin. And assuming here long pin, the heat transfer through the pin is given by Q equal to under root of HPKAC multiplied with a theta B. And that can be substituting all the values. H10, P is 2.01, K is 50, and AC is 0.005 multiplied with this theta B or a delta TB is 80 degrees Celsius given in the numerical. After calculation, 5.025 into 80 under root of 5.025 into 80, that is 2.24 into 80, and the heat transfer is given as the 179.2 watt. Next part is that calculating the efficiency for long pin. The efficiency of the long pin and end insulated pin or convection from the pin tip is given as the tan hyperbolic ml by ml by this equation. Eta equal to tan hyperbolic of 8.97 multiplied with 0.05 by 8.97 into 0.05 the denominator. That is equal to tan hyperbolic of 0.4485 by 0.4485 and that is 0.421 by 0.4485 and that will be after the calculation we are going to get 0.938 or 93.8%. This is about the efficiency of the pin. This is the second problem on the pin and further I am going to solve some other numericals. Thanks for watching. If you like, share, subscribe and comment.